To learn how to draw block diagrams, let's look at a simple example of a coffee maker. The water and the ground coffee go in, and coffee comes out. So when we draw the block diagram for this, the block is the part, component, or subsystem, in this case, the coffee maker. The arrow lines are the signals, in this case the inputs of ground coffee and water on the left, and the output of coffee on the right. Our coffee maker needs power to operate as well, but we often ignore the power connection when drawing block diagrams. We assume the power is given. Let's look at another example, a home heating system. Here you are at home, watching TV with the remote in your hand. You feel cold, so you turn the thermostat up to 21. The temperature in the house is cooler than this, so the thermostat controller sends a signal to the furnace valve to add more fuel to the furnace. This adds heat to the home, hopefully more heat than is lost through the roof. Before we draw the block diagram for this system, let's remind ourselves of the parts of the system. We had a furnace, heat loss, desired temperature, sensor, valve, gas, and a house. To draw the block diagram for this home heating system, we will start with a generic closed-loop block diagram and then label the specific components as they are in the home heating system. In closed-loop control, every system has a controller, which performs decision-making functions, an actuator, a plant or process, and a sensor. These are represented by blocks. In terms of signals, there is the set point, the error, and the output. The set point is the desired output. This gets compared to the sensed output, and an error is generated. Based on the error, the controller commands the actuator, and the actuator action causes a change to the input to the plant, which causes a change in the output variable. In our temperature control system example, the plant is the house and furnace together as a system. The output is the temperature in the house. This is what we are trying to control. The actuator is the furnace valve that we adjust to control the gas flow to the furnace. The furnace valve is controlled by the thermostat controller, which compares the desired temperature to the sensed temperature, and based on the error decides whether we need more heat or no heat added to the house. The sensed temperature comes from the temperature sensor. This sensor feeds the output temperature back to the controller. Thus, this is a feedback system. We should also consider disturbances, such as heat loss, which would happen through the roof or windows and doors. A disturbance is something that affects our output, but that the controller cannot control.